Good afternoon, everybody. How's everybody doing today?
Good. Very good.
Welcome to my presentation. This is my final senior design presentation of design of the Climate Surgical Center. My partner, Philip Hyde. My advisors is Dr. Angela Rasmussen and Callum Poole. This could be you. What will happen if the power system fails right when you get cut over? It would not be a good news. So, me and my partner, our mission is to design and develop a stable power system that will improve the electrical safety and reliability. This is the block diagram that I use. The bottom part is what I use. So my milestone one is designing the AutoCAD and learning about the AutoCAD. Until then I had no experience of AutoCAD, so you'll see how I overtake the challenges. So in this project, I'm going to be going over the purpose of the project, specific goals, my results, and my conclusion. So this is where the Climate Surgical Eye Center will be designed. So my purpose of doing the part of my project is to design the power plant, lighting plan, fire alarm system, and one-line diagram for this Climate Eye Surgery Center. So in order for me to achieve my tasks, I heavily relied on IECC 2014, NEC 2014, NFPA 2012, and as well as power system analysis and design work that helped me a lot on calculations. So the tools that I use towards my achieving my target is AutoCAD electrical as well as SKM power tools. So the reason I used AutoCAD electrical is I got architectural drawings from the architectures, drawn drawings, and I need some sort of engineering software to convert it into the industrial standard for presenting for city and any other needs that need to be done. So after I got a hang of AutoCAD, I started my design on the Climate Surgical Center. This is one quadrant. Of 4 quadrants. This is one quadrant of the power plant design. My partner went into great detail describing about the power outlets and how it's set up. So the reason I did this is 4 quadrants is easier for me to detect if I'm making a mistake. I can easily track back and correct it rather than designing it all in a one. So in yellow it indicates the circuit numbers, light blue indicates where the power outlets are located, and the dark blue wiring is the interconnection with the fire alarm system, and over here on the red you'll be able to see all the fire alarm systems. So this is the final finished power plant design. So as you can see, I still have the 4 quadrants left there. So this is the OR area, which is the operating area, recovery area, doctor's lounge, and the visitor area. So after I design this, my next task is to design the lighting plan. So I use the same method, I divide it into 4 quadrants when I'm deciding this. And the challenge I faced here is scaling. The scaling has to match exactly to the actual field. So if for some reason, if this need to be replaced, they know the scaling and they can directly go and figure it out from AutoCAD rather than finding it. The red here is the emergency battery pack that we use for lithium-ion batteries. So this is the finished lighting plan that I did. So as you can see, I still have the 4 quadrants here. So when I was designing this is in Arlington, Texas. Everybody knows Arlington, Texas is extremely hot and humid. So what can I do to save some energy in this facility? As you know, a light bulb, a regular light bulb will produce a lot of heat. So to overcome that, the air conditioning has to work as twice as hard because there's so many lights being 24/7. So I proposed, why don't we use LED lighting? So there's no heat as well as to mitigate of the amount of energy being used. So they approved it, so I feel accomplished on that. And next is to design the fire alarm system. We use the same fire alarm system for Twin Falls and Climate Surgical Center. Philip spent numerous hours with the phone with Twin Falls, and I was attending those, and he attended mine when he contacted the Arlington Fire Department. The reason this is very important is if, for example, if this fire alarm goes on, the fire department, while they're arriving, they know where to go and where to tackle the fire, rather than finding out, going into the building, asking everybody, hey, where is the fire at? People may know, people may not know. But this way, it eliminates the factor that they know where to go and how severe the fire is before it is, then they'll be able to address that. So this is the one-line diagram that I designed for Climate Surgical Center. This side is the utility. This side is the emergency site generator. So the challenge I faced designing this is labeling, because this has to be in a one drawing. I cannot put two different drawings into it. One drawing, and labeling is up to get it into task and make sure all the details that they require is there. So that's a little bit of challenge that I faced. So now let's look at here, and the next task is to perform a short circuit analysis. One may ask, what is a short circuit current? Short circuit currents are induce the large amount of energy in forms of heat and magnetic force into the electrical system. So if you have a short circuit current, what does it do? This is what it does. This is an actual arc flash occurring on a control panel. It's not pretty. What's an arc flash? Arc flash is a phenomenon where the inrush currents leaves its indented path and finds the easiest way through one conductor, air to another conductor, or through human to ground. So doing a short circuit analysis, it'll give us an indication of how much is the risk level on each breaker, each panel. So we can address that going on forward. So what did I use to calculate all the arc flash and short circuit analysis? I used SKM Power Tools. It's a very powerful electrical engineering software that is industry leading over 40 years, which simplifies the power system calculations. In this specific project, I used it for automate the electrical design, calculations, arc flash evaluation, as well as short circuit analysis. This is my one-line diagram. So when I was doing the one-line diagram, I wanted it to look exactly like the AutoCAD. So if there's a problem happening somewhere, if an engineer needs to replace this main breaker, he can replace it and then test it on SKM, and then immediately go redline it on AutoCAD rather than trying to find it in AutoCAD. So making it look exactly identical will make the engineer's job a lot easier down the road. So that's a challenge that I faced, as well as per unit analysis in this case was a little bit challenging for me because it's a lot of equipment and a lot of different currents being produced at different levels. So working on that, it took quite some time to get everything right. So next is, why did we do a coordination study? The reason we did a coordination study is at any point of the electrical system, if there is a failure or fault happening, we can easily identify it and easily tackle it down and find solutions for it, rather than going through all the steps, finding out, okay, this is what it is, and this it's a lot easier. So the way I address the SKM is, when I use the emergency side, I need to figure out what is the primary generator that's being used. Is it zigzag or Y-connected, delta Y-connected, and delta connected? So once I identify it and put it into SKM, okay, this is the type of generator that we are using, and then I need to select, is it bus side, line side, or load side? In all these cases, I ran it in bus side, line side, and load side, and worst case scenario. So that way, if something to happen, I know what's the worst that could happen, rather than running it in just the general mode. So once I configured the SKM and I ran the study on a selected area, I get a TCC curve, which is a time current curve. My partner went into great detail explaining it, so I'm not going to repeat myself here. So once I get the TCC curve, I know what is the risk level, what is the instantaneous energy, and the time the generator main breaker it takes to activate. So this will give me an indication of what is the category levels of the risk hazard. So one may ask, what is a category level? So United States has graded from PPE, personal protective equipment, 0 to 4. 0 being this, FR clothing, hard hat, some pair of goggles, and steel toe boots and safety gloves. You can easily perform the tasks you need. Category 4 is 40 calories per centimeter squared, which is pretty much you need to have a moon suit to work on live line, which is extremely uncomfortable. I got the chance to wear one out in the field on my internship, and it's not fun. It's hard, and the mobility is extremely limited. So the reason I brought this up is these are my results. So a couple of the generator main breakers are sitting at Cat 3, which is you have to pretty much wear a moon suit in order to perform any kind of operations onto it. So after finding out the short-term time delays, short-term pickup time, and I was able to reduce most of them from category 3 to category 0 PPE. So is this means like anytime the generator kicks in, the breaker gonna activate and shut off the power system? No. So the newer type of breakers it's extremely smart. So this is an example of a Cutler hammer generator main breaker that we use. So this here is the DCC curve setting. You can manual dial it, or in our case, we had you can program the computer and you plug it in and you can flash the existing DCC curve to the new one. So then once we do that, then the generator main breaker knows, okay, it initially takes 6 times the current to start up the generator. Once it starts up, all you need is 1.5 times to safely operate. So I was happy I was able to achieve that task from my prior experience and all my engineering classes knowledge that I gained. So in conclusion, this project you're working on real world challenges. Failure to coordinate properly will result in catastrophe, as we know. So the following codes theory will prevent us from electrical failures. So overall, we improved our knowledge on AutoCAD, Revit, and SKM power tools. Got a deep understanding of how the DCC curve relates with coordination studies, as well as the arc flash and short circuit analysis. These are my references that I used throughout my senior project. But there's one thing that I want to bring up onto, it'll be not fair if I leave it blank. My inspiration is the only way to do great work is to love what you do. So from get-go, I love what I do, and especially the power and electrical engineering, and couldn't be happier to do a senior project that involved arc flash and everything. So I thank you for your time, and now it's time for questions.
In your list of codes, you did not mention NFPA 70E.
Oh.
And yet you did talk about arc flash. You want to talk a little bit about that?
Yeah, NFPA 70 code book, I heavily use that as well to do the calculations. One of the things when I was doing the calculations with SKM, trying to compare with the NFPA 70E, I'm not getting the same number that SKM is producing. So I was looking at the book, and then I went to the class book that I use for the power system design class, and I was looking through the notes, and I figured out what I'm making a mistake of the square root of 3. And I had that there, and I was like, could this be? So even though NFPA, I used NFPA, it just says, okay, this is what it is, this is how the calculations are done, and it just follows through. It never mentioned the square root of 3, just like skip steps. So on the design-wise, when I'm doing SKM, I use the NFPA quite heavy. But the interesting thing is when I was looking at the index, they say, okay, 100 and A3. So 100 is not the H100, it's the equation 100. So that's on the go learn process.
What was your highest category then that you ended
Cat
up
3.
with? Cat 3.
Cat 3, that's the highest I had.
And then they used that. You said you had a programmable breaker that you can actually laptop program now.
So you can flush it. The reason they came up with that, Cutler hammer, because when the people are dialing it manually, so when they take the screwdriver off, it can either adjust up or down. So if it sits between 1 point, if it needs to be 2, and if it sits at 2.5 or 1.5, it's not going to perform what it's supposed to do. So therefore, they came up with the error protection. You just little handheld device. You tell them what it is, what is the new TCC curve is, and it'll give you a little description. Okay, this is how it is. Is it approved? Approved, and then flash it into the software. It's really good. So.
You talked about some of your lighting design.
Correct.
Did you have to look at lumens and the actual light intensity on work surfaces and so
Yes.
forth? And how did you go about doing that analysis?
They gave us 800, 900 luminance that needs to be, this is the room and this is how bright it should be. So when I was looking at contacting industrial companies for LEDs, I just told them, hey, this is what I'm looking at. How many LEDs that I need to do here? Some of the companies says, oh, we don't provide surgical. You had to contact this other company. So there's a little bit of runaround. Got through it, and calculation-wise, once I know the lighting that it need to be in at that room and what the LED is doing, just set and balance it. So that's how I overcame that challenge.
Did all the circuits need to be backed up by generators, or like refrigerators and things like that?
All the circuits, including the power, yeah, pretty much everything, even a simple outlet, need to be backed up by the generator. So when we did the bus to line to load side, everything, we didn't specially say, okay, we are eliminating this because it's not relevant. We combine everything into a one big package. And